Assalamualaikum and salam sejahtera. My name is Muhammad Solihin bin Maliki. My metric number is B0518200088 and my supervisor for this project is Professor Madya Dr. Mat Nizam bin Abdul Rahman. I am from Faculty of Manufacturing Engineering. This presentation is for my final year project 1 BMFU 4912. The title for this project is Influence of Laser Machining Parameter on the Quality of the Machined Surface During Machining of Alumina. This is my presentation outline. First is introduction, second is problem statement, third is objective, fourth is literature review, fifth is methodology, and lastly is expected result. Now I would like to share my introduction. Alumina ceramic or aluminum oxide is utilized in various industrial applications including vehicle engine, heat exchanger, and electronic substrate for microwave device. The mechanical properties are brittleness, high hardness, high electrical insulation, and high corrosion resistance. The physical characteristic that we can see is the color that generally comes with white color and is nearly colorless. When alumina is machined by conventional technique, the tool easily to wear or break and cause the damage on workpiece surface. And lastly, the laser cutting process is preferred for cutting alumina due to its unique properties such as non-contact process, no mechanical cutting force, no tool wear, flexibility, and high machining rate. Second is my problem statement. Conventional machining such as diamond saw, the cutting process will cause the tool wear problem or easily break the tool and workpiece because the properties of alumina are very brittle and hardness by Yan 2012. That cutting process will also produce the resultant residual stress that reduce the alumina final strength by Bernsley 2020. Third is minimal material removal is hard to achieve and the probability of burr formation occurring is significantly higher by Email 2019. The CO2 laser machining also comes with challenging issue on how to minimize thermal damage, eliminate micro crack, achieve a high quality cutting edge, and minimize the sputter, dross, and recast layer by October 2016. Third is my objective. First objective is to optimize the CO2 laser machining process parameter for maximizing the alumina cutting process quality by using the DOE method or design of experiment method. Second objective is to identify the significant critical parameter that influence machining surface quality by using the ANOVA method. And last of my objective is to determine the cutting parameter optimization and mathematical model by using response surface methodology or RSM. This is scope of experiment. Study the effect of using CO2 laser machining to perform the alumina cutting process due to brittle and hardness issue. The material used in this experiment is limited to alumina ceramic due to its unique thermal and mechanical properties that make it challenging to machine. Study the appropriate cutting parameter used for the cutting process such as laser power, cutting speed, and frequency to solve the several issues such as crack. Identify the appropriate method to minimize the surface roughness, heat effector zone width, and curve taper angle that can cause failure in the final process. And last for the scope is the development of the data and analysis method will carry out using the response surface methodology or RSM to evaluate the cutting machining parameter. My fourth content is literature review. First journal is Fast Femtosecond Laser Ablation for Efficient Cutting of Sintered Alumina Substrate by Ostbik 2016. The objective is study the effect of focal length, depth, laser power, number of pass, and material translation speed upon the machining of sintered alumina. The parameter used is power 500 mW. The focal length is 100 mm. The speed is 2000 micrometer per second, and the material is sintered alumina tie with 250 micrometer. And the result is 2000 millimeter per second with 14 pass is better quality compared to 1000 millimeter per second with 7 pass that has a lower quality. Second journal is Laser Cutting of Alumina Metal Matrix Composite by Marimutu 2019. The objective is to understand the essential characteristic of continuous wave laser cutting of aluminum metal matrix composite reinforced with aluminum oxide fiber. The parameter used is power 1400 watt until 1700 watt. The speed is 2000 until 3000 millimeter per minute, and the material used is alumina with thickness 2 mm. The result is the optimization parameter to decrease the surface roughness. The speed must be amount 3000 millimeter per minute with gas pressure 13 bar, and the power is maintained. The third journal is Effect of Process Parameter on Machinability Characteristic of CO2 Laser Process used for cutting stainless steel by Rajesh 2019. The objective is to investigate with a focus on modeling of CO2 laser cutting parameter like laser power, cutting speed, gas pressure as input parameter, while surface roughness and curve width are observed as output response. The parameter used is power 600 watt, speed is 2000 millimeter per minute, gas pressure is 0.4 bar, and the material is stainless steel with 3 mm. The result is surface roughness increase with cutting speed and laser power. For curve width, laser is the primary influence factor, followed by cutting speed and gas pressure. Fourth journal for my literature review is Experimental and Theoretical Investigation of Fiber Laser Crack-Free Cutting of Thick Section Alumina by Yan Li 2011. The objective is to study the indicate that a transition from compressive to tensile stress can result as the laser cutting parameter change, which is beneficial to resisting the crack formation. The parameter used is power 1000 watt, pass with 5 mm second, frequency with 13 Hz, speed with 1.5 mm per second, and the material used is alumina with 6 mm thickness. The result is the single pass crack-free cutting can be achieved using high laser peak power, short pulse duration, and low pulse repetition rate, whereas the feed rate has dual effect depending on the acid gas emission. And the last journal for my literature review is CO2 laser peeling of aluminum oxide ceramic and application for the polishing of laser cut surface by Yan 2013. The objective is to generate a smooth subsurface on alumina ceramic. The parameter used is power 20 to 25 watt, frequency there is no frequency, speed is 60 to 140 mm per second, and the material used is alumina with 1 mm thickness. The result is the chip thickness is among 500 micrometer. The roughness of the form subsurface is around 2 micrometer, which is close to the mechanical backing 1.84 micrometer. The microstructure of the form subsurface is similar to the base material. From the literature review, the proposed method is by using CO2 laser machining. CO2 laser machining machine is the best method to perform the machining process of alumina ceramic because alumina physical and thermal properties are not suitable to fabricate by using the conventional or another machining method by Ostbeek 2016. Second is, compared to the other technique, CO2 laser machining can provide profile cutting with relatively high surface cutting edge quality and precision at low cost by Yan 2012. And last is, CO2 laser machining did not degrade the final quality of the alumina machining area because the potential for plastic deformation and surface residual stress is shallow by Yan Lee 2011. Fifth is methodology. When the experiment starts, it will begin with experimental design, execution of experiment, data collection, data analysis, and optimization. And if the optimization is accepted, it will continue with report writing until end. The experimental design is, the experimental metric will be created using Design Expert software version 13. And the machining parameter involved are laser power with range 50 to 150 watt, cutting speed with range 800 to 4000 millimeter per second, and the frequency with range 1000 to 3000 Hz. And surface roundness, heat affected zone, and curve taper angle are the output response measure once the experiment is complete. For the execution of experiment, the type of laser machining used in this project is CO2 laser machining, and the model is MHL 2512 HV2 minus R plus. And the type of material is alumina or aluminum oxide, which is a 99.7 ceramic plate with a dimension of 80 mm times 80 mm times 30 times 3 mm. And the data collection by the Mitutoyo EJ-301 surface roundness tester measure the surface roundness on the machining area at the alumina workpiece. And the scanning electron microscopy, same model ZIS Evo 50, measure the heat affected zone and curve taper angle. And for the data analysis, the data will examined by Design Expert software, which will arrange all the output response data into a metric. And the ANOVA analysis will be carried out, and the best parameter will be determined using a mathematical polynomial equation. The type of design of experiment used in this experiment is response surface methodology or RSM, and the tool is central composite design or CCD. The total run that has been generated is 19 run with 13 input factor, 5 center point, and 2 level that is lowest and highest. And the output that need to be measured is surface roughness, hash width, and curve taper angle. This is photo for CO2 laser machining model MHL 2512 HV2 minus R plus. And the second picture is alumina ceramic, and the third photo is Mitutoyo EJ-301 surface roundness tester that used for measure the surface roundness. And scanning electron microscope, same. The photo like in this slide is for measure the heat affected zone and curve taper angle. Lastly is expected result. The problem is to obtain the significant parameter, and the solution is development of mathematical model for the cutting parameter and output result. After that, we can optimize the cutting parameter from the mathematical model and achieve the optimal value for the surface roundness, hash, and curve taper angle. And that's all from me. Thank you.